Hello everyone, today we'll be going over general science and how it relates to the TEAS test. So the first overall theme is the metric system. You'll encounter this in essentially any science class you take, or any science you'll encounter even in the TEAS test. A good way to remember the order is with an acronym. And the acronym that most people generally see is this one. King Henry died while drinking chocolate milk with 3 months and 3 nuns. As you can kind of see that the acronym follows along with the kilo, 1,000 or whatever units, it's meters, 1,000 meters, hecto, deca, deci, centa, milli, and the 3 months are also incorporated there as well. So it's just an easy way to kind of see how the systems change, but you'll definitely want to get more familiar with this chart before you take the TEAS test. So the next theme is accuracy and precision. The difference between the two is kind of outlined pretty well in this chart, or in the picture, I should say. So if you have very low accuracy, very low precision, you're kind of scattered over the target. Nothing's really close together, which would say how precise you are. And you're also not really hitting the dead bullseye of the target, meaning you're not very accurate. Kind of branching off of that, you'll see here in the one to the right that low accuracy is you're very far from the target, but high precision. You're at least hitting the same mark constantly, which is a lot easier to work with. So you can kind of just have to hone in your sight to get it closer to the target. Or you can also have high accuracy, but low precision. So you're hitting the target, but you're kind of still a little scattered. You're still going a little bit, you're a little bit going, you're hitting the target, but you're kind of still spaced out a little bit. You're not fully in that small zone of the accurate target. And then you have kind of the perfect balance of both, where you have high accuracy, high precision. You're hitting the center of the target, and you're also only hitting the center of the target. Next is the experimental design, which is one of the overall arcs of most sciences as well. In an experiment, you're aiming to test a hypothesis, some kind of question you ask of some general sense, whatever it may be. And then you start to do some background research, kind of get a feel for what your question was. Then you start to construct a hypothesis. So at that point, once you have an overall idea of what you're looking for, you can kind of say, well, how do you think it's going to play out? What do you think is going to happen if you start to do the experiment? And then once you have a full hypothesis, you can begin trying to test an experiment based on it. You have to know what you're looking for to kind of test whether it's true or not. And then it kind of becomes this cyclical process of you test it, is it working? Yes. Are you able to draw conclusions? And then you kind of say, well, was I right with my hypothesis or was I wrong with my hypothesis? And then communicate the results. So this is what we're saying to the TEAS test is you may be given a system some person used or an overall arc of an experimental design that somebody did. You may be asked, what is their hypothesis? What was the results of their experiment? That sort of thing. And kind of going a little deeper into this overall design, you generally have 3 variables that you're working with. One is the control, or comparison variable. So you need to know what a correct answer looks like, or what a true or negative result looks like. And that's what the control does. It gives you something that you can base your research on. Because if you're going to find out something's right or wrong, you need to have something that you know is true. And then also you have the independent variable. This is the variable that you manipulate. So you're changing this variable, or you're tweaking it based on whatever your experiment may be, to then affect the dependent variable. And this is the value you measure. This is the value that you'll look for, and you'll try to see, this will be the variable you look for to see kind of the trends or whatever your experiment may be. So you could also be asked, well, what was the control of this experiment? Or what was the independent variable? Or what variable you were trying to measure? They could ask you any small detail of the experimental design that you'll have to sort of fully be able to answer the questions, you need to have a good idea what the experimental design has in it and what it's comprised of. So next we're going to go into a little bit of chemistry. So the first overall thing of chemistry, or the very broadest sense, is atoms. Those are the things that make up matter, and they're also the smallest unit of matter. Atoms of a single type are referred to as elements. And then these atoms can combine and bond together to form compounds or molecules. And as you can kind of see from the picture to the right, you'll see a small dense core in the middle, which is referred to as the nucleus. And it has both protons. Those are the positively charged molecules you'll see with a little plus sign in there. And you also see neutrons. Those are the neutral red particles kind of outlined in the legend in the image. And you have a cloud of electrons that are the negative charged particles floating around. And this example here is carbon, which we'll go a little bit into how you would know that with the next slide. So here is the periodic table, kind of a table of elements that are ways of categorizing these elements into easy to use table on all current existing elements. You don't have to know every single aspect of the periodic table for the TEAS test. The main ones to focus on are carbon, nitrogen, oxygen, fluorine, sulfur, kind of the main the main yellow compounds on the table, or like the main focus as you'll normally see in the body and that sort of thing. So yeah, definitely don't focus on the entire periodic table, just mainly the key elements kind of in the first, usually the first 2 rows, or the first 2 to 3 rows are the major elements you'll see kind of commonplace within the TEAS test. So to kind of get a familiarization with the periodic table, you need to know how to read the periodic table, or how to break down all those tiny squares. So first off, the atomic number is the number of protons. That's outlined in the 6, right below the carbon. Next, you'll see the atomic mass, which is down below. In the carbon example, it is outlined as the 12.011, and that is all the different numbers of neutrons, and it's the mass of the weighted average. So with carbon as an example, carbon comes in a mass of 12, a mass of 13, and I believe a mass of 14 as well, but that's not really too important for this slide. But just a weighted average of all those possible isotopes that carbon has. And then one key thing they try to touch on a lot in the TEAS is that elements share similar properties down a column. So that means if you go down one column, all those elements have some more or less similar properties that you can that help you kind of outline, oh, well, I don't know what this element does specifically, but I know it's similar to, say, oxygen, because it's in that same column. And stable elements have equal numbers of protons and electrons. That's not the most important information, but at least something to keep in mind, because they can ask you it, and we've seen example questions where they've brought it up at least. So ions, atoms with charges, due to unequal protons and electrons. So these will be the ones, if you've taken chemistry, you'll see like carbon 2+, so like sodium+. You'll see a little superscript charge. And if it's a positive charge, that means there's less electrons, meaning the protons are dominating in this element example. And then if it's a negative charge, that means there's more electrons. That means it's more negative, and the electrons are in more abundance in this element. And here is the arrows kind of outline where stuff is. So next is kind of already what I touched on a little bit, is that these elements can bind together in different bondings to form molecules. Kind of the example you've probably seen the most is water, or H2O. These bondings they combine using their electrons. You have ionic bonding, which is a complete transfer of 2 electrons, and that is kind of a big example is like normary salt, sodium chloride. Sodium gives up an electron, chlorine fully takes that electron, and they bind together in opposite charges. And then also kind of the in-between, not as strong, is covalent bonding. That's kind of outlined in this water example, and also in another example is hydrogen chlorine, or that's a type of acid. So nonpolar is the bonding of an equal sharing of electrons. Polar is unequal sharing. So here you have one that's a little more electronegative or more greedy, as you could say, of electrons, and then it's going to pull those electrons towards it more than towards the, say, the less polar region. And that's another example of how water bonds. Here you have oxygen, which is very electronegative. It much more prefers the electron, and you have hydrogen, which not so much. So when they bond, more of the electrons will pull towards the oxygen, and you'll have a net dipole in that direction. So with all that in mind, the main thing is knowing the different types of bonds and then how they react. And then kind of touching on that react, you have a list of reactions you kind of get familiar with if you've taken chemistry, or if you've taken chemistry, and then you've probably seen all these common reactions. First, you have combination, which is kind of the synthesis of two molecules. They form together to create one molecule. Then you have decomposition, which is kind of the reverse order of that. This is just a breaking down of a molecule into two either elements or just smaller molecules. Precipitation is a little harder to it's a little harder to explain, but essentially it is two solutions of salts are mixed. So two elements that can fully ionize in water are then brought together, and then when they react, one of the combinations produces a precipitate, meaning a solid is formed and it kind of clumps at the bottom. Again, if you've taken chemistry, you've probably done a lab where you mix two, usually it's like copper solutes, and they come together and they clump to form a little like orange or blue solid at the bottom. That'd be the precipitate, which would show you that this was a precipitation reaction. Then you have neutralization. That's when an acid and a base react together and they produce salt and water, meaning they fully neutralize and they essentially cancel each other out, as you kind of think of it. Then you have combustion, which is an oxygen combines with a carbon type molecule to then form carbon dioxide and water. And these reactions are exothermic, which just means they give off heat. That's all you really have to know from that. As you can see, the general equation is provided there. The key points to note is the oxygen with some random organic molecule. Here it's represented as A. And then that produces water and carbon dioxide. So that'll be the key things you'll look out for that type of reaction. Next, you have displacement, where one element essentially trades places. You'll see with the A plus BC that the B kind of gets booted out and represents its own molecule, whereas the A takes the place and becomes AC as a molecule. So some of those I touched on with the precipitate reactions. You bring a solution into water. So another way of looking at that is how dilute or how concentrated something is. So you can actually measure that with an equation. So if you say you add more water or more volume to a solution, it becomes more diluted because you're not changing the amount of solute you're not changing the amount of solute you have. All you're really doing is adding more water. So they become more spaced out or the concentration decreases. So that equation is outlined as C1 V1 equals C2 V2. Here is the concentration in the first state, C1, times the volume in the first state, V1, will be equal to the concentration in the second state times the volume in the second state. So that means no matter how much water you add, if you add a lot of water in the first state, you'll get much less concentration in the second, and so on and so forth. And you can always solve for one of the variables and to find out one you're lacking. So they may give you, there was 20 milliliters in the first, and at the beaker at time 1, and it was 20 moles. Then I go, okay, we added 30 milliliters of water to the solution. What is the final concentration? And you can move around that equation to find the answer. And now we'll move on to pH. But this is essentially how acidic something is. The main thing to know is it measures the amount of hydrogen ions. So an acid is any compound that releases those ions, essentially to make it more acidic. So kind of one of the examples I brought into the lecture was hydrogen chloride. So when it forms in the water, that H breaks off and essentially makes it more acidic. A base is any compound that releases OH into the solution. That kind of counteracts the H because the OH and H combine together to form water, which will make it slowly more basic if you add more and more. Usually you'll see a chart kind of similar to this, where the scale goes from 0 to 14, where 0 is the most acidic types of molecules, and then 14 is extremely basic. So you'll see lemon juice kind of teetering on more the acidic side with the 2. Blood is a little more on the basic side, just a little bit above, with regions you'll get into probably later in science courses, where you see it's a little basic. Then baking soda, much more basic in the 9 region, and then bleach, highly basic in the 12.6 region. So with all that in mind, that's all I have for you in the general science. And further lectures will be going over more topics in the TEAS test.